From the direction of the outward arrow, we can tell this is an NPN transistor. The lead connecting to this short bar is labeled as base B. The lead connecting to this arrow is labeled as emitter E. The last lead is labeled as collector C. The labels B, C, and E are optional. They are given for the convenience of discussion. In order to get the transistor working, we need to connect power supplies and other components to bias the transistor. This is the base emitter biasing circuit. This is the collector emitter biasing circuit. If VBB is larger than 0.7 volt, a base current will flow through the base emitter junction, the PN junction here. The direction of the current flow can be visualized with the structural block diagram. If VBB is larger than 0.7 volt, a base current will flow through the base emitter junction. If there is a base current flowing through the base emitter junction, there will be a collector current flows through the NPN transistor from the supply VCC. The emitter current is the combined current of the base current and the collector current. We can also use the structural block diagram to visualize that. This is the base current from the supply VBB, and this is the collector current from the supply VCC. They combine together and flow out the emitter region as the emitter current. So IE is equal to IB plus IC. This is essentially the concept of Kirchhoff's current law. The sum of the current flowing into a node is equal to the sum of the current flowing out of the node. Besides the currents, two voltage differences must be discussed in the study of BJT. They are VBE, the voltage difference between the base and the emitter, and VCE, the voltage difference between the collector and the emitter. But what are VB, VE, and VC? As emitter is connected to the ground, VE is equal to 0 volt. VB is the voltage at the base with respect to the ground. To rephrase that in common English, VB is the voltage difference between the base and the ground. Similarly, VC is the voltage difference between the collector and the ground. So you should be able to understand the meaning of these two equations now. Next, we will look into the biasing circuit of a PNP transistor. In this circuit, the emitter is connected to the positive terminals of both power supplies. A base current is driven by VBB and flows through the emitter base junction, a PN junction here. See this green circuit path. And at the same time, a collector current is driven by VCC and flows through the PNP transistor. See this blue circuit path. The emitter current is the sum of the base current and the collector current. As before, this concept can be visualized easily with the structural diagram. The emitter current consists of two components. One is the base current, and the other is the collector current. IE is equal to the sum of IB and IC. That's true for both PNP and NPN transistors. Of course, this agrees with Kirchhoff's current law.